Okay, in this lesson we are going to look at vector addition. In the previous lesson we looked at vectors, their magnitude and their direction. We looked at some of the symbols and notation. This time we're going to take vectors and look at how we add them. And the first way we're going to look at adding them is geometrically. Basically, vector addition is just going to take a vector, and we'll call this vector u, with its direction and magnitude right there. And we want to add another vector to it. I'm going to take the next vector v with a different direction and a different magnitude. And when I add these two things together, what I have is a vector or a force acting in this direction, and then another vector or force in this direction. And what happens when I put them together is ultimately I ended up starting here and ending up here, my initial and terminal points. This is called the resultant vector. When I add vectors, u plus v is the resultant. The resultant vector, and sometimes you'll see it as sum vector, and that's obviously because we added. So geometrically what's happening is that we have our initial point of our first vector and the terminal point of our second vector. And what we're doing then is basically calculating the magnitude or distance of our resultant vector. So for example, let me give you a picture here. In this picture we have a vector u with an initial point at 1, 2. Its terminal point then is at 2, 7. And we want to add it to this vector v, given right here, whose initial point is at 5, 5, and its terminal point is at 10, 3. And what we're going to do with this when we add them is we're just going to take the terminal point, or I'm sorry, the initial point of v, and we're going to slide this up here, translate it, so that v's initial point will start at u's terminal point. So we're just going to slide it up. We're going to keep the same direction, or in other words, the same slope that this has, and we're going to slide it up here. And when we do that, what we get then is a picture that looks like this, where we started at 1, 2, we took this vector v and we slid the vector so that its end is the end of u is also the beginning of v, and now we see we have addition of vectors, and we can calculate this resultant vector that's created. And the way we do that is we're going to calculate the magnitude or the distance of the resultant vector. So the resultant vector, remember doing this, is basically the distance formula. Our initial point is at 1, 2. Our terminal point now is at 7, 5. And so in order to calculate a vector that has an initial point of 1, 2 and a terminal point of 7, 5, we use our distance formula for finding the magnitude of the resultant vector u plus v. So that means that we are going to do, again, a squared plus b squared equals c squared, which is how we derive the distance formula. So it's just our x values, 7 minus 1 squared plus 5 minus 2 squared Okay, so 7 minus 1 is 6. 6 squared is 36. 5 minus 2 is 3. 3 squared is 9. So we're looking at the square root of 45, which I can simplify. I'll take it all the way out here. 45 is the same as 9 times 5. I know that the square root of 9 is 3. So my resultant vector has a magnitude of 3 square root of 5. Now again, I'm using distance formula. You could use a squared plus b squared equals c squared. What this does for us is it begins to introduce something that we know as a parallelogram law. And basically the parallelogram law says that if I take these vectors to add them together, any vector, my vector u and my vector v, no matter where they're at, I can put them end to end. So we can take u and I'll take a vector u, and then I'll take my vector v, and this is a new u and a new v, not the same as the one I was working before, but any vectors, and I can put them end to end. I can put them end to end this way. Or I could put them end to end. This is how we did it before. Or I could redo this. I could put them end to end this way. Here's u. Here's v. When I do it like this, you notice if I slide this over, I'm going to slide this over here, I'm getting something that starts to look like a parallelogram. If I didn't want to put u here, let's say I wanted to slide and put it over here, go v first and then u and add them together. I could do v first and then u. Well, if I did v first from right here over and then u and up, I get this. So if I do u plus v, I could start here and do u plus v. But that takes me to the exact same point as if I were to do v plus u. V first, then u. This is the commutative property in algebra. Geometrically, we call it the parallelogram law. It means that no matter what order I do my vectors in, u plus v or v plus u, I end up at the same terminal point with the same resultant vector. No matter what, this is either u plus v or v plus u. It is the same resultant vector. So what we can do with this is if we have two vectors, we can take them in either order and basically work through a squared plus b squared equals c squared, or work through our magnitudes and our distances to find our distances of our resultant vectors in either order, and it won't matter. When we have two vectors that are, well, let me go backwards. Let's look at this a little bit backwards. Let's say I tell you about a resultant vector. We're going to use this law to work backwards to find a resultant vector. If I have two forces and the result, I have two forces that are going to act in perpendicular directions to each other. Perpendicular directions to each other. So one going this way, we'll call that force F. And let's have one going this way. We'll call it force G. That's a perpendicular. And force F has a magnitude of 16 and force G has a magnitude of 12. The resultant vector is just the diagonal of this rectangle here. And I know that because I could take this vector and slide it up, or I could take this one and slide it over. I can do this parallelogram law geometrically. I know that the diagonal is my resultant vector, F plus G. So in order to find the resultant vector, or the magnitude of the resultant vector, what I can do is I can go back through a squared plus b squared equals c squared. We'll do it that way this time. 12 squared plus 16 squared equals c squared. So I have the square root of 144 plus 256 is equal to c. Let's see, that's the square root of 400. So my resultant vector has a magnitude of 20. All right, so we have a magnitude of 20 for my resultant vector F plus G. The next question we will go through is, remember, vectors have to have magnitude and direction. Let's see if we can figure out direction of this. So in other words, I want to figure out angle theta. And in order to figure out angle theta, I can use a little bit of trig. I have an opposite and I have an adjacent. I also have a hypotenuse. I could use the hypotenuse. So I can use sine or cosine or tangent or any of those things. I'm going to go ahead and use tangent. The tangent of theta is equal to the opposite over the adjacent. So on my calculator, I'm doing inverse tangent in order to find the angle of 16 over 12. And I get approximately 53.1 degrees. So my resultant vector has a magnitude of 20 and a direction of 53.1 degrees. All right, let's look at another example here. Let's look at an example where the forces are not perpendicular. Let's look at an example where we have a 5 Newton force and let's take a 15 Newton force. The direction for our 5 Newton force is 40 degrees. And we want to find the resultant vector. When we add these two forces together, what is our resultant vector? So we'll use our parallelogram law. We know that we're going to be looking at the diagonal for our resultant. And in a rectangle, in the original rectangle, if this angle over here was 40 degrees, then this angle is the same side supplementary angle has to be 140. They are supplementary. They are same side interior angles, so they are supplementary. All right, so what we have then is 15 Newton force here 5 Newton force here, 140 degree included angle right there, we're going to have to use the law of cosines in order to find this. Since it's not a right angle anymore, we're not just using SOHCAHTOA, we're going to use the law of cosines. And I'm going to call my resultant vector D just for now, so we have a name for him. My law of cosines then, D squared is equal to 15 squared. We'll see if you can remember the law of cosines. That was a while ago. Plus 5 squared minus 2 times the 15 times the 5 times the cosine of that included angle, so the 140. Okay, so let's see what we've got here. We have 225 plus 25 is 250 minus 2 times 15 times 5. Let's see, 2 times 15, 45, or I'm sorry, 2 times 15 is 30 times 5 is 150. Cosine of 140. We're going to have to do our multiplication here first before we subtract. So, and then I'm going to take the square root of this. And all of this I'm just going to put on my calculator. So when I put this on my calculator, I get that D is let's do an approximately equal to 19.1. Okay, so I have a magnitude for D. I used the law of cosines to get my magnitude. Now, I want to find the direction. I want to find this angle right here of my resultant vector. And now that I have that D is 19.1, I have an angle and a side opposite. I want this angle. I have the side opposite. To find the angle now, I can actually use the law of sines. So to find my angle, I'm going to set up the law of sines where I have 5 over the sine of theta equals 19.1 over the sine of 140. And as I solve this, I'm going to cross multiply. And then divide. And then I take the inverse sine of all of this. And my theta is approximately, when I put on my calculator, 9.7 degrees. So I have the magnitude of my vector and I have its direction. Okay, so that's it for this lesson. I'll see you at the next lesson.